हेलो एवरीवन, वेलकम टू स्टैट्स मैट सिंपल। क्या आपने कभी सोचा है कि एक रियल बिजनेस प्रॉब्लम रॉ सेल्स डेटा से कैसे मीनिंगफुल इंसाइट्स हम ले सकते हैं यूजिंग आर। आज हम वही करने वाले हैं। सपोज यू आर वर्किंग एज ए डेटा एनालिस्ट फॉर ए रिटेल कंपनी। द कंपनी ऑपरेट सेवरल स्टोर्स with the information like sales, expenditure, profit, age, categories, and geographical regions. Now we want answers to some important questions like which product is the generate most sales? Does advertising actually influence sales? Which store are performing better and which type of customers do we have? So we will start with hist function. The historic histogram function create for the cells. On the x-axis, we will have cells data. From the histogram, we will see how cells data are spread. The distribution appears symmetric or skewed. Next comes the plot function. The plot function is used to see how scattered data between expenditure and cells. We will place advertising on the horizontal axis and cells on the vertical axis, and each point represent one store. Scatter plot give us immediate visual impression of the relationship between advertising expenditure and sales. Now we want to compare product categories. To compare product categories, we will use bar plot and pie chart. Both are used to compare category but with different visualization. Now, if you want to fit a linear regression model and want to add its fitted regression line, then we will use AB line function. This helps us to visualize the estimated linear trend between advertising and sales. If we want to add the extra point, then we will use the point function. The point function will do the same thing. Add will add extra additional points to the existing plot. Now, if you want to add monthly sales figure for an entire year, then you will use lines function. This will tells you the sales are increasing or the sales are falling. If you want to add some text, extra text labels, then you will use the text function. Whenever you have multiple groups, symbols or lines, you want to add a legends. The legend function will use to represent how much categories or group you have in the graph. Now, if you want to use the par function will control the graphical parameter and arrange multiple plots on the same graphics. Now we will learn some matrix operation on quarterly sales information for several stores. We organize the sales figure into a matrix. The row represent stores and the column represent the quarter. If we transform this matrix, then the row and column will switch. The quarter become rows and the stores become the column. It is a simple operation but extremely useful in linear algebra and data manipulation. If you want to solve linear equation of this matrix and want to get inverse of this non-singular matrix, then use solve function. The solve function will use mathematical and statistical calculations. With diag function, you will get the diagonal elements from existing matrix. With the row sums, you will have sum of each row that represent a store. And with the column function, with the column sums, you will get sum across the column for each quarter. Now we have converted our sales data into useful summaries. What happens when the company has hundred or thousand of observations? We don't want to repeat the same calculation manually. So we will use apply family for that. If we use the apply function, it will perform calculation across the rows and columns of a matrix or array. Like calculate average quarterly sales without writing separate commands for every column. And lapply will store elements as a list, sales, profit, and advertising. With lapply, you will get the mean of for each element and return as a list. Apply simply work but attempts to simplify the result whenever possible. It returns your output results in a convenient vector or matrix. The mapply is useful when our function needs corresponding elements from multiple inputs. Like if we want to combine prices and quantities to calculate revenue across several products, then we will use mapply. Now, if we want to understand our customer, then we will move from store to customer. Our dataset contains categorical variables such as product, category, and reasons. So, factor allow us to represent categorical variable efficiently in many statistical models. By using the as dot factor, you can convert reason character data to factor data. And now, if you want our customer range from 18 to 65 years old, they don't want individual age. They want customer segment. Then use cut function. The cut function divides age into meaningful intervals such as young, adult, middle age, and seniors. A continuous variable has now been transformed into categories. It can support segmentations and reporting. Now, if you want to do some statistical analysis, for deeper statistical analysis, you will use the quantile function. With quantile function, you will get first quartile, median, third quartile of cells. This summary will help you understand distribution and positions within the dataset. Now, if you want to generate some random number with uniform distribution, then use our unif function. It will generate hypothetical sales values within a specified range. The correlation function, the COR function, is used to see correlation between advertising, advertising and sales. The positive correlation indicate higher values of one variable tends to occur with higher values of other. The negative correlation indicate an inverse association, and the close to zero indicate weaker linear association. Now we will use the LM function. LM function allow us to fit linear model. We will fit linear model using advertising and profit as a independent variables. To get the summary of this model, we will use the summary function to find out R square, coefficients, and significant test. Now, if you want to see how these R values are centralized or not, so use scale. Scale allow us to center and standardize these values. This is especially useful technique in PCA, clustering, k nearest neighbor, and support vector machines. Now, the ABS function is used to find out the error between actual cells and predicted cells. That will give you the magnitude, not the direction. Now, think about everything we have learned. We started with the raw retail data, created histogram, built scatter plots, compared categories, analyzed matrices, automate repetitive calculations, categorized customer, calculated quantiles, generated random numbers, measured calculation correlations, regression models, and standardized variables. Finally, calculate prediction error. This is the thing we have learned in this month. If you like this journey from day 31 to day 59, then follow us, subscribe us.